Hi guys, so let us discuss about another problem. It is called moving zeros to the end of an array. So what does this problem state? So we will be given an array. Okay, let us see this array. And in this array we're gonna have elements like 1 and whatever elements. But in between whenever we have the value 0, but whenever we have the value 0, we have to move it to the end of an array. So if this is the array, okay, if this is the array, the output array that I want should be like this. So 1 should come first, and then 2 should be here, and then 3 should be here, and then 4 should be here, and then the rest should be zeros. So we have to move all the zeros to the end of an array. So what is a very intuitive way of solving this question? It's just you will just iterate through the array. So whenever you find a 0, you're going to remove it from the array and then place it and then append it to the back of array. So let us see what does it work. Will this work? So let's take an array. Let's take a is equals to some 1 0 0 2 0 3 0 4. So let's see this array, and what we're going to do, we're going to iterate for I in a. If I is equals to 0, then I'm going to remove that value from array. So a dot remove, I'm going to remove the value I, that is a 0 always, and I'm going to append the value I to the end of the array, and let's print the array. You have to print an array without a for loop. You can just use this asterisk symbol before the array. It will just print the array. Let us see what we do. Okay, so we got the answer, but is this an optimal? Because we're not trying to solve a question. We're trying to understand the different ways of solving it. So yes, this does work, but to remove an element from an array, it might take, if you know, on a in the worst case, the time complexity could be of order n, and to append an array, it could also be of an order n. So together internally they might end up being an order of n squared complex algorithms. So we need to come up with something optimal. So what can we do? So can we swap elements and make every 0 move to the end like we do in the bubble sort? Okay, let's try. So let us have an index I here, and let us say we have index j. Okay, we are going to strategically place these two indexes such that I will always point to the first 0 element and j will always point to the first non-zero element. So let's take, so j will point to the first, so let's, so I will point to the first non-zero element which is here, and j will point to the first non-zero element here. So we're going to do the swap. So here we have 2 and here we have 0, and then we'll move I, and j will iterate till it gets a non-zero element. So it's gonna move to here, and when I have a condition where I will always point to 0 element and j is pointing to a non-zero element, I'm again gonna do the swap. Now we got 3 here and we get 0 here, and I will move to the next. Okay, now I again have 0 and j will again go and point to the first non-zero element, which is here. And now again I'm going to swap these two. So I get 4 here, and I'll get 0. And then j reaches to the end of the array, so we'll stop this loop. So can you find something? We actually got the exact answer that we wanted, but how? It's actually how the way we are comparing. So we are making sure that any element that is a non-zero is being replaced by a 0. So that the ordering is always preserved, as well as all the zeros are moved to the end. So okay, so how can I write an algorithm for this? So let us define. Okay, so we have an array. So the first thing that we have to do is, okay, let's take, we have I and j. So we'll have two variables. Now I need to place I at an index where we have our first 0. So I have to iterate through the array, but okay, this is going to be a very small iteration, although it seems that I'll be iterating till end, but eventually we will find 0 in the first or second place. So it's going to be a short loop. So for I in A, actually we need the index, so it's better if we use range, in range of n. But what is n? We need to define n. N is the length of array. So for the length of array range n, I'll be checking if the a of ith index is equals to 0. If it is equals to 0, I'm going to place my I. Okay, I need my left index, right? So instead of using I, let's say my left. Initially, let's have it point to a -1. So if I have a value which is 0, then I'm say my left pointer will have the value I, and I'm going to break out from this loop because I have found my first 0 element. And then my second loop, my second for loop for j. So the j will start from, okay, it may start from I plus 1 because I itself is a 0, so it's not needed that we need to start from. So let us say I will start from j will start from I plus 1. So j in range I plus 1, and it will go till n. And so what are we comparing? We'll be comparing if, so we know that I is always on 0. I'm trying to find an element which is a non-zero element. But is it I think better using should be, yeah, okay, let's use instead of let's keep it I, and let's keep this loop iteration as it, and let me assign I equals to it. Okay, so now we have value change at I plus 1. So this looks a bit clear, so I kept it I. Okay, so what are we going to do? We're gonna see if the j is if the array of j is not equals to 0. So we have found a non-zero element. If it is not equal to 0, we have found a non-zero element. Then what should we do? We need to swap a of I with a of j. Right? We can use a temporary variable, but I think let's write something more Pythonic code. So we're gonna say a of I, comma a of j will be a of j, comma a of I. Very intuitive statement to swap numbers. So we have swapped it. So what should we do after this? So I will have to I will be pointing to some value, but j will be an iteration, but I should be incremented. So I is equals to I plus 1. I will point out to the next element. So after this iteration, the array should be the way that we wanted. Why did I write plus minus? Okay, now let us try to print this array and see if this code works fine. So remember the star operator, you can just print it as it is. Okay, let's run. Yes, we got the output that we wanted, but to be sure, let's take the input from the user and try out for different combinations and how it works. So to take input, to take an array as input, there is a kind of a scary syntax. It's a list of map of int comma input dot split. Okay, that's a lot of functions. Let's try to see what each of them say. So this is just our input function. It's going to return as a string. So we are going to split the string with a space character. I mean the default split will be done via a space character. So we will have a character array with this, or a character list, and we are going to map each element of this list to a function called int. So int function is going to convert all the integer values which are encoded as a string by the input function to the integers. So we have a map function, and we have the integers, as a map object. So we don't want a map object, so we are converting it into a list. So that's all this thing. So in this way we can get an array. Okay, let's give the same array that we want. Okay, I think maybe a prompt would be a good thing. Okay, I need to stop it, and then okay, let's say enter. Now let's run this. Okay, I'm gonna give an array that is 1 0 2 0 3 0. Need to give the space, right? 1 0 2 0 3 0. Okay, so we got the output that we wanted. Let's try for another one. Okay, let me give 1 0 0 0 0 0 and 2. Fine. So this code is working, and that's it. And the complexity of this code is just n, and I think that's still fine because uh, I th I think it is an optimal code. We don't need any more optimizations. So this will I think this is fine. Okay, so uh, that's all. I think we'll meet in another video.